Students, in last session the theory of general term, nth term of arithmetic progression is completed. Let's see some examples related to nth term of arithmetic progression. Let's see the formula. an is equals to a plus n minus 1 into d. It is formula to find nth term in which a is called first term, d is the common difference, small n belongs to the capital N. Whenever we need to find 10th term, we are using A10. A10 is used to find 10th term. A10 is equals to a plus 9 into d. Now how it is come? It is come from the formula an is equals to a plus n minus 1 into d. Instead of small n is equals to 10, a plus instead of n is 10 minus 1 into d, a 10 minus 1 which is 9d. Same way we have to find another terms like this. Suppose we need to find 51st term, a51, then a51 is equals to a plus 50d. Instead of n we have to substitute 51. a51 is equals to a plus instead of n is 51 minus 1 into d, where a plus 51 minus 1 is equals to 50d. Whenever we need to find the terms, we are using simple form of a and d, not by using formula each and every time. There is no put the substitution of the formula an is equals to a plus n minus 1 into d. Let's see the example 3 from our textbook. Find the 10th term of the AP 2, 7, 12. The first of all AP is given. First write the AP. Given AP 2, 7, 12 up to infinite. The first term a is equals to 2. Common difference d is equals to second term minus first term. 7 minus 2 is equals to 5. We need to find 10th term. 10th term which is a10 is equals to a plus 9 into d. How it is come? By using the formula n is equals to a plus n minus 1 into d, where a is equals to 2 plus 9. Instead of d, common difference d is equals to 5. 2, 9 5s are 45. 45 plus 2 which is 47. 10th term is 47. Hence the 10th term of required AP is 47. Now we see the next example for which term of the AP 21, 18, 15 up to infinite is minus 81. Also, is any term 0? It is our second question. Give reason for your answer for our second number. In first one the AP is given. First of all write the AP. Given AP 21, 18, 15 up to infinite. Now from this AP we have to write first term and the common difference. First term a is equals to 21. Common difference d is equals to 18 minus 21 is equals to minus 3. First term a and common difference d is available here. Now what is our question? Which term of this AP is minus 81? We don't know which term. Let us take it is nth term. Let nth term is minus 81. That's why nth term means an is equals to minus 81. From this formula we are using formula to find nth term a plus n minus 1 into d. Instead of an, a plus n minus 1 into d is equals to minus 1, and we find the value of small n. A is equals to 21 plus n minus 1 as it is, and D is equals to minus 3 is equals to minus 81. Now we make n minus 1 into minus 3 as a subject. We get n minus 1 into minus 3 is equals to minus 81. Shift minus 21 left hand side to right hand side, it will become minus 21. That's why n minus 1 into minus 3 is equals to minus 81 minus 21 is equals to minus 102. Make n minus 1 as a subject, we get minus 102 upon minus 3. Minus minus cut. Cut is possible. 3 3s are 9, 3 4s are 12. That's why n minus 1 is equals to 34. That's why n is equals to 34 plus 1. And therefore n is equals to 35. N is equals to 35 shows that which term of the AP is minus 81? 35th term is minus 81. Here 35th term is minus 81. To verify that it is correct or not, find the 35th term. 35th term means A35 is equals to A plus 34 into D, where first term A is equals to 21 plus 34 and the common difference D is equals to minus 3. 21 as it is minus 2 1 102. Now we subtract it 1 8 and minus 81. It is correct. It is a verification how the term 35th term is minus 81. The first question is completed here. Now the second one. Second, also is any term is 0. Same procedure will be repeated here. If it is any term is 0, then take an is equals to 0. Whenever we get small n belongs to a capital N, then our answer is true. A plus n minus 1 into D is equals to 0. That's why first term A is 21 plus n minus 1. The common difference D is equals to minus 3 is equals to 0. By making n minus 1 into minus 3 as a subject, we get minus 21. N minus 1 as it is equals to minus 21 upon minus 3. Minus minus cut, 3 7s are. That's why n minus 1 is equals to 7. Therefore, n is equals to 7 plus 1. N is equals to 8 belongs to n. Here small n belongs to capital N. That's why the 8th term of the AP is 0. Here small n belongs to capital N. Therefore 8th term is 0. It is possible. What is our answer for this question? Because small n belongs to the capital N. Let's see the next example 5. Example 5 is determine the AP whose third term is 5 and seventh term is 9. Here in word, third term is 5 and seventh term 9 is given. Write it in symbolic form. Third term A3 is equals to 5 and seventh term A7 is equals to 9. We are using third term A3 is equals to 5 first. A3 is equals to 5. We know A3 written in form of A and D. A plus 2D is equals to 5, which is our equation number 1. And the next one, A7 is equals to 9. That's why instead of A7 is A plus 6D is equals to 9, which is our equation number 2. Determine the AP means first of all we need to find the first term A and the common difference D. The situation is given here. We are obtaining here the two equations. We are solving this equation using the elimination method. A both are equal. We subtract both the equation. You know what is our elimination method very well. Subtract equation 1 from equation 2. a plus 6d minus a plus 2d is equals to 9 minus 5. That's why a plus 6d open the bracket minus a minus 2d is equals to 4 plus minus a is got 6d minus 2d is equals to 4d is equals to 4. That's why d is equals to 4 upon 4 cut and we get the value of d is equals to minus 1. Here the d is obtained. Now we substitute value of d in any of the equation 1 or equation number 2. We substitute it in equation 1. Substitute d is equals to 1 in equation number 1. Our first equation is a plus 2d is equals to 5, where a is as it is 2 instead of d is 1 is equals to 5. A plus 2 is equals to 5. That's why a is equals to 5 minus 2. Therefore, a is equals to 3. Here the value of a and the value of d is obtained. Now we find the AP. Now to find AP we require first term a1 is equals to a is 3. Second term a2 is equals to a plus d, where a is 3 and the common difference is plus 1, which is 4. Third term a3. See, the third term is already given in the question. Third term is 5. You can write it directly. A3 is equals to 5 from the question. A4 is equals to a plus 3d. A is 3 plus 3. D is equals to 1. 3 plus 3, which is 6. Therefore, required AP is 3, 4, 5, 6 up to infinite. There are lots of terms in the AP. Hence the example 5th is completed. Let's see the next one. Let's see the next example. Example number 6. Check whether 301 is a term of the list of numbers 5, 11, 17, 20, 3 up to infinite. We know how to check it is any term of AP or not. In previous example we learned about it, but it is not AP given, it is a list of number. Then first of all we have to check the given list of numbers are AP or not. Given list of numbers 5, 11, 17, 23 up to infinite. The first of all to check it is arithmetic progression or not, we have to find the difference between two consecutive terms. A2 minus A1, 11 minus 5 is equals to 6. A3 minus A2 is equals to 17 minus 11 is equals to 6. A4 minus A3 is equals to 23 minus 17 is equals to 6. Here the difference between two consecutive terms are equal. Here A2 minus A1 is equals to A3 minus A2 is equals to A4 minus A3. Therefore, given list of numbers form an AP. Now it is AP, then we have to check 301 is any term or not. For that, first we write first term A is equals to 5 common difference D is equals to 6. If any term is 301, then first of all we have to take here, let us take nth term is 301. That's why nth term an is equals to 301, where an is equals to a plus n minus 1 into d is equals to 301. Now we have to substitute the value of a and d, where a is equals to 5 plus n minus 1 as it is, instead of d is equals to 6 is equals to 301. By making n minus 1 into 6 as a subject, we get 301 minus 5. That's why n minus 1 into 6 is equals to 301 minus 5, we get 296. That's why n minus 1 is equals to 296 upon 6. The cut is possible by 2 1s are, 2 4s are 8, 148 and 2 3s are. N minus 1 is equals to 148 upon 3. That's why n is equals to 148 upon 3 plus 1. To simplify it, we get n is equals to 151 upon 3 by taking LCM. We know small n belongs to compulsory capital N. It does not belongs to capital N. Here the small n does not belongs to capital N. We can say that 301 is not a term of given list of number. Here small n does not belongs to capital N. Therefore 301 is not any term of given list of numbers. Let's see the example number 7. How many 2-digit numbers are divisible by 3? How many numbers divisible by 3? But condition is that the numbers are 2-digit number. We know the smallest 2-digit number is 10 and the largest 2-digit number is 99. But we have to take here the numbers divisible by 3. First of all, we have to write here 2-digit numbers are divisible by 3. First is 12, because started from 10, then 11, then 12, add 3, 15, then 18, up to 99. 99 is also divisible by 3. It is a finite AP. We find the number of terms in this AP. It is the answer of our question. First write the first term. First term A is equals to 12. Common difference D is equals to 15 minus 12, which is 3. We know the last term. Last term is called by an or L, as we know. An is equals to 99. Here we are using concept of an, nth term. An is equals to 99, where an is a plus n minus 1 into d is equals to 99. The value of n gives how many numbers they are divisible by 3 and 2-digit numbers. First term A is equals to 12 plus n minus 1, common difference D is 3, is equals to 99. By making n minus 1 into 3 as a subject, we get 99 minus 12. Therefore, n minus 1 into 3 is equals to 99 minus 12 is equals to 87. That's why n minus 1 is equals to 87 upon 3. 3 2s are 6, 3 9s are 27. That's why n minus 1 is equals to 29, and therefore n is equals to 29 plus 1 and n is equals to 30. Here the answer is obtained. How many 2-digit numbers are divisible by 3? 30. Therefore 30 numbers, 32-digit numbers. Therefore 30 two-digit numbers are divisible by 3. Let's see the example number 8. Find the 11th term from the last term towards the first term of the AP 1074 up to minus 62. It is also a finite AP. It is an important example because we need to find 11th term from the last, not a single 11th term, 11th term from the last. Given AP 1074 up to minus 62. Whenever we find term from the last, first write the AP in reverse order. Reverse order of given AP. Last term becomes a first term and first will become a last term. Now how to obtain second last term? See here, in given AP the common difference is minus 3. 7 minus 3 is 4. To obtain the previous term, not succeeding, previous term, 7 plus 3, 4 plus 3, we have to add plus 3 to the minus 62, we get minus 59. Again we add plus 3, we get minus 56 up to 10. The difference is opposite in reverse AP. Now we write first term and common difference. First term A is equals to minus 62. Common difference D is equals to minus 59 minus of minus 62. Minus 59 plus 62 is equals to 3. Here the common difference is 3. We need to find the 11th term from the last in given AP, but we find 11th term from this AP. Therefore A11 is equals to A plus 10D, where A is equals to minus 62 plus 10 and D is equals to 3. Minus 62 plus 30. Minus 62 plus 30 is equals to minus 32. A11 is equals to minus 32. Here 11th term in reverse AP is minus 32, but it is 11th term from the last in given AP. Therefore minus 32 is the 11th term from the last term of the given AP. Keep in mind, example number 8 is important example. Let's see the next example. Let's see the next example. Example number 9. A sum of rupees 1000 is invested at 8% simple interest per year. Calculate interest at the end of each year. Do this interest is form an AP? It is our first question. If so, find the interest at the end of 30 years, making use of this fact. The first of all, principal amount P is given 1000 rupees. P is equals to 1000 rupees. Rate of interest R is equals to 8%. Simple interest per year we have to calculate here. For the first year simple interest, we know the simple interest I is equals to PRN upon 100. Interest for first year is equals to P is equals to 1000, R is equals to 8 and N is equals to 1 upon 100. 2 zeros are cut and we get 80 rupees. Same way interest for second year is equals to 1000 into 8, but instead of n it is second year, then 2 upon 100. 2 zeros are cut, 8 2s are 16, 160 rupees. Next, interest for third year is equals to 1000 into 8 into third year means multiplied by 3 upon 100. 2 zeros are cut and our answer is 240 rupees. Same way for the fourth year, interest for fourth year is equals to 1000 into 8 into 4 upon 100. 2 zeros are cut. 320 is equals to 320 rupees. It is interest for the fourth year. I1, I2, I3 and here is the I4. It is list of numbers. Therefore, list of numbers first is 80, 160, 240, 320 up to infinite. Now we can check, do these interests form an AP? It is list of number for the interests. Now we discussed it is form of an AP or not. A2 minus A1. 160 minus 80 is equals to 80. A3 minus A2 is equals to 240 minus 160 is equals to 80. A4 minus A3 is equals to 320 minus 240 is equals to again 80. Here the differences between the two consecutive interests are equal. Here A2 minus A1 is equals to A3 minus A2 is equals to A4 minus A3. Therefore, these interests form an AP. These interests form an AP. Now the second question, interest at the end of 30 year. Interest at the end of 30 year is equals to given by A30, which is question mark. Interest at the end of first year, which is first term. Interest at the end of second year, it is second term. Interest at the end of third year, it is third term. And the interest at the end of 30 year, it is called 30th term, A30. We know A30 is equals to A plus 29D, where first term A is equals to here 80 plus 29 instead of D is equals to 80 is equals to 80 plus 29 8s are 0 as it is 2 7 2 3 2 0 and our answer is 2400 2400 rupees. Interest at the end of 30 year, it is 2400. Let's see the next example number 10. In a flower bed, there are 23 rose plants in the first row, 21 in the second, 19 in the third, and so on. There are 5 rose plants in the last row. How many rows are there in the flower bed? In a flower bed, there are flower in rows. The first is 23 rows in first row, 21 in second, 19 in third, and so on. But there are 5 rows plants in the last row. We don't know last row which is our last row, but there are 5 rows plants in the last row. It is finite AP. The first term A is equals to 23, common difference D is equals to 21 minus 23. 21 minus 23 is equals to minus 2. We know the last term AN is equals to 5. We find the how many rows are there in the flower bed. Let us take n numbers of rows are in the flower bed. That's why AN is equals to 5. We know the formula to find AN. AN is equals to A plus n minus 1 into D is equals to 5, where A is equals to 23 plus n minus 1 as it is, instead of common difference D, which is minus 2, is equals to 5. By making n minus 1 into minus 2 as a subject, we get 5 minus 23. 5 minus 23, n minus 1 is equals to 5 minus 23, which is minus 18. Therefore, n minus 1 is equals to minus 18 upon minus 2. Minus minus cut 2 9s are. N minus 1 is equals to 9. Therefore, n is equals to 9 plus 1 and n is equals to answer is 10. Now, the completed how many rows are there in the flower beds? There are 10 rows. Therefore, there are 10 rows in the flower bed. If you are verifying using n is equals to 10, find A10. If A10 is 5, then answer is correct, where A first term is equals to 23, 9 instead of D is minus 2, 23 minus 18, we get 5. A10 is equals to 5. There are total 10 rows. 10th is the last row. Last row containing 5 roses. Last row containing 5 roses. That's why A10 is equals to 5 is obtained here. Here the verification is completed. The example from our textbook is completed here. Now, whenever we meet in next session, we discuss our exercise.